Dear students, let's start lecture number 13 on the topic polymorphism. As you know, this is second lecture on polymorphism. So, this is our outline. Today we will discuss polymorphism, types of polymorphism, static polymorphism and dynamic polymorphism. Static polymorphism is also called overloading, and dynamic polymorphism is called overriding, and we'll explain that with the help of examples. And then I'll give you assignment at the end, and then I'll show you references which I have used for preparing these slides. And then we have question answer session. So let's revise lecture number 12, which was on the topic boxing, unboxing, casting, implicit and explicit casting, and then method of casting in C#.NET, which are available to do casting in C#.NET. So as you know that we have boxing and unboxing. So we have types, as you know, we have data types to store values in, uh, in programming languages. So we have two kind of data types, value types and reference type. So value type, as name indicates, that they have values, and reference type, they as they their name indicates that they hold reference or address. So here you can see in value type you have integer, float, double, and in the reference type you have a type object. So if in a situation you want to convert value type to a reference type, when you convert a reference type, a value type to reference type, this is called boxing. And when you convert the reference type to value type, this is called unboxing. So here you can see that as we studied that we have, we have different kind of data types available in programming languages, especially in C#.NET. Like we have integer, float, character, double, and in the reference type we have object. Here you can see that this is the standard nomenclature of C#.NET programming language, so I don't want to go into detail of that. Here you can see that we have value 100, and we have object type, and I am assigning the value type to object type. Here you can see that this is done implicitly. You know, the science or the rule of the thumb is that you can convert a smaller type to a bigger one without mentioning anything, because the baseline is where you don't have any loss of value, where you don't have loss of value. So compiler does that for you implicitly. But where there is a chance of loss of value, you have to you have to do that explicitly. So here you can see that integer can convert is assigned to object value without any explicitly mentioning to compiler that I want to convert this. So no need to do that. You are simply assigning your integer value to object value, and this is done implicitly. And here I am replacing I with 200. So when you display this, you see that I have 100, and I have the obj value is also 100, because here we have 200 because I have replaced I. But here io object, which is a variable of object type, I have value of 100. So you know that you can directly convert the value type to reference type. This is called boxing. And on the other hand, when the reverse of this happens, so this is called unboxing. Here you can see that the same, I have an object and I have a different kind of value types available. So here you can see that when I converting the object to, or I am assigning the object to a value type, I have to mention it explicitly. Okay, because the object uh, mm, type is object type is bigger than value type, so there's a loss of value can happen. So here you have to mention that explicitly. You can see here that as I am converting object type to integer, so I have to mention integer here. And if I want to convert float, so I have to mention float here. And if I want to convert double, so I have to mention double here. And similarly, when it converted into that particular type, you must have that type of variable here to store that value. And then uh, I'll printing those two and getting the same result. So when you convert the value type to reference type, this is called boxing, and when you convert the reference type to value type, this is called unboxing. Now let's start with casting. I'll explain that in my second or third language, if third lecture, if you remember. But I want to revise it here because now you have two kind of conversions, like on the top when you convert the value type to reference type, or a reference type to value type, and uh, inside of a value type. Like for example, if you want to convert the integer to float or double, or a reverse, so this is called casting. So and here again we have a two type of casting: implicit casting and explicit casting. In implicit casting, this is done automatically, as I mentioned. When you convert when you want to assign a smaller value to a bigger value, so you need not to mention explicitly, because we uh, don't have uh, don't have a chance to lose our value, so you can do that automatically. So compiler does that for you without getting anything explicitly you need to mention. So you need not to mention that. So converting a smaller type to a larger value, larger type size. So for example, if you assign, as you know that character is of 1 byte, or 1 byte, character is of 4, long is of 8, float is of 8, double is of 8. And for example, if you want to convert the character to integer, or integer to long, or long to float, or float to double, you need not to mention explicitly, because compiler knows that there is no chance, no loss of value chances here. So you can do that implicitly. And in explicit casting, when you convert the larger value, okay, larger type of value to a smaller size, or smaller type size of value, so compiler knows that there's a chance, there's a value loss of value can happen. So you need to mention here explicitly, like here you can see that integer, when you assign the integer to double, this will be done automatically, you need not to mention explicitly. But here, for example, if you want to in explicit casting, if you want to convert the double to integers, you know double is of 8 byte and integer is of 4 byte. If you want to store that, so there may be a chance of loss of value. So compiler asks you to do that explicitly. Compiler does not do this for you implicitly. You need to do it explicitly. So this was a casting, and these are the conversion methods which are available. You can replace the previously studied methods, and you do the .NET method. Like in the .NET, you have a conversion class which helps you to convert one type into another type. Like for example, you can use this method to convert into boolean. This method is used to convert it to double and string, and this is 32 for integer and 64 long for long, as you know that. Here you can see that how it will be done practically. So for example, if you this is your integer value and you want to convert it into string, so you can do that by using this convert class, and this is toString method is used to convert your integer value to string. Similarly, you can do the casting here by using the convert class, and this is the method, and you can do this. And this is for the for the integer type, and this is for the string type, if you want to convert the bool into string. So let's start lecture number 13, which is on polymorphism. As we know that polymorphism is a Greek word, and it stands for many type of the same thing, like many classes that are related to each other by inheritance. As we mentioned in our previous lecture, that in inheritance, when we were discussing polymorphism, I have given an introduction of polymorphism in my previous lecture. So I mentioned that for the polymorphism, you need inheritance. This is the key to remember, because without inheritance, you cannot create the scenario or situation of polymorphism. So you need inheritance for that. Inheritance let us inherit field and methods from another class, which is normally it's parent class. Polymorphism uses those methods to perform different tasks. So in a polymorphism, you have a parent class and child class, and as they have same signature of method, so they will perform different tasks according to that specification. As you know that in inheritance, if you have a parent class, so normally we call it as generalized class, and we have a child class, and the child class is normally called as specialized class. So normally, you know that when you have a hierarchy of inheritance or a level of inheritance, so you normally make object at uh, uh, um, at the specialized class. You don't have object of your abstract class. So this allows us to perform a single action in different way. For example, think of a base class as animal, and in animal you have a method that is called animal sound, and derived class you have a pig, dog, cow, or anything which you could consider an animal. And they also have their own implementation of animal sound like pig, ox, and the cat meows, etc. So I think now you got the sense that in the polymorphism we have a same kind of action, same kind of a method, but they perform different kind of actions. Okay, so here you can see that we have polymorphism. There are two type of polymorphism: static polymorphism and dynamic polymorphism. A static polymorphism, when two or more method having the same name with different number, type, or different type, number of order of argument. So we call it as static polymorphism, or in other words, you can say that this is static polymorphism. So same class is known as overloading, static binding. Normally, when binding is performed, when you have an object in traditional object oriented, we have studied this. So for when you have an object and you send the uh, message to send a message to your method, that which method of that class will be called. So you do that by using binding. So normally binding is performed at compile time. So in overloading, as you know that the binding is performed at compile time, which is also called early binding. Here you can see, I'll explain that with the help of example. Like for example, in static polymorphism, you have same method, like we have a sum method here, but this method has two arguments. So how they will be differentiated, or how compiler differentiates these two. By compiler differentiate on the basis of their type, number, and order of arguments. So here you have two arguments. And here we have three arguments. So compiler differentiate on the basis of these rules. So here you can see that I have a calculation class, and I have an object obj, and obj, now I am performing binding. So you can see here that obj, this is the object name and this is the method name, and I am passing, as I am passing three parameters, so this will be called three parameters method, like I have this one. And here I am binding this object with this, and I am passing the calling two two parameters method, which is this one. So this is called compile time binding, because at the compile time, compiler knows that which method of the class will be called. So before the compile time, compiler knows this. So once the compilation is done, this is fixed and cannot be changed later on. So that object, here we have object obj, this will be called only that method which is bind with that object. So this is called uh, compile time binding. Now, for the dynamic binding, we have some condition which need to be met. Like you must have inheritance and you have overriding. This is a condition of dynamic binding, which is also called overriding. You, as you know that. Here you can see that we have a class animal. Like you can understand this is this programming this programming through this diagram. Like we have a parent class which is called animal, and in animal class we have animal sound, which is a method, and we have two child classes. Like we have a pig and dog, and the pig and dog, they are overriding the same method which is parent in their parent class. So normally it is defined that when when the same method is available in two different classes and they have the relation of inheritance, this is called polymorphism. Normally this is the definition of Java or other object-oriented languages, but this is not true for C#.NET. I'll explain that with the help of example, that why this is not true for C#.NET, or what will be the behavior of this this concept in C#.NET. So here you can see that we have animal class, then I have a pig class which is derived from animal class, and I have a dog class which is derived from animal class. So according to the previous programming languages or other programming languages like Java or other programming object-oriented languages, this concept will be called as a as a polymorphism. But you can see here that how it works in C#.NET. Like for example, you see that I have created the created object of my parent class, and then I have assigned my first object like pig, which is a class. So I assigned the pig class object to my parent class, and you can do this if you have the concept of casting, because the subclass or a child class can be assigned to parent class without explicit casting. So compiler knows this. So you can assign the child class object to the parent class. Here I am assigning the same as dog class parent to dog class object to my animal class. And here I am doing the function of binding. So my animal, which is the object of my parent class, and I am binding parent method, and here I am binding uh, methods with the object of my both child class like pig and dog. But you see the action of this programming paradigm. You see that we are getting the same message for all these three functions. Why? Because this is not the because this is cannot be done in C#.NET. That this is the concept of overriding. This is not the concept of overriding in C#. Like I have mentioned that in other programming languages we say that if you have um, if you have a same method in two different classes and having the relationship of inheritance, we call it as a polymorphism. But this concept doesn't work in C#.NET, as I depicted depicted this concept here, and you see the reaction of those methods. So all the methods, they are using the parent class method. They are not overriding it. So why? Because this concept is a little different from other object-oriented languages. I mentioned this, that if you want to perform this, you need to use some modifier in a in a parent class, like you make it like virtual or abstract, and in a child class you have to use override for that if you want to perform the process of overriding. So Polymorphism C# provides an option to override the base class method by adding the virtual keyword. As I mentioned, that here in C#.NET you need a virtual keyword or a abstract keyword if you want to allow your child class child class to perform the process of overriding, and then they will write the keyword or a modifier override to override that, and by using the override keyword for each derived class method, as I mentioned earlier. But this is not true for other programming languages. This is especially we are consider the concept this concept under C#.NET. So in C#.NET provides an option to provide the override the base class method by adding the virtual keyword. So if you have the virtual keyword with your parent virtual keyword as a modifier in your parent signature and override in your child class method, then you can override that. You can see here that we have animal class and then we have virtual method. You can see now we have add modifier virtual here. Now we are allowing our base child class to override this method over virtual void animal sound, and you can, and when the child classes will override, they will write the override keyword here as a modifier to override the parent method. Then the concept of overriding will be implemented. Here you can see that we have a override same. The dog class is overriding the method of animal sound, so this will be overridden. So, and here you can see that dog animal, and now this is also overriding, dog is also overriding the parent method animal sound, and now the overriding will be done. Here now you can see that we have a first we first we uh, first we are making object of our parent class, and then I'll making object of my derived class, that is pig, and assigning to my parent class, and then I making object of a dog class and assigning to my parent class animal. And here you can now you can see the reaction that when I write my animal dot animal sound, so animal so the base class method will be called, and when I write my pig animal sound, so the pig says we, so the child class method which is a pig class will be called, and here the dog class will be called. So now we got this concept that if you want to if you want to use the concept of polymorphism, we have to use we have to use virtual keyword, virtual keyword with the method of our parent class, and child class will write override to override that. And now this is your assignment. You take any example of virtual overriding, virtual overriding, and send it to me. And you can take the example of both, like static and dynamic, and then in the dynamic you will take the example of virtual and send it to me. I want to mention one thing more, that we call this virtual polymorphism is optional polymorphism as well. I'll explain that in my next lecture, that why this is called optional optional overriding or optional polymorphism. So these are the sources which I have cited for making these slides, so you can explore these to learn more about it. If you have any question, you can ask me uh, through KCMS, or we have a WhatsApp group. You can ask me. I'll be more than happy to answer your question. But if you have a question, please don't don't overlook those questions, because in programming language, if you do not understand the concept, you will not be able to learn the programming, because this concept will also be used in when we will be studying exception handling, or exception handling and other very important concepts. So you need to learn uh, all those concepts. So if you have a question, please ask those questions. I'll be happy to answer your question. With that, thank you. Till next lecture. Allah Hafiz.